Good morning, Manish.
Good morning, sir.
So, in the last class, we are calculating the how much current will flow to the armature current. Sorry, through the armature at the time of starting. So, the equation of armature current from the motor equation, what we get? Manish, Ayush, Deepak, anyone? What is the equation of the armature current from motor equation? We get Ia is equal to, tell me, Manish, am I audible? Manish, am I audible? Ayush?
Yes, sir.
Okay. First, tell me the equation of armature current which we actually get from the motor equation. This is
V minus EB
V minus EB
by RA.
by RA. And we took the value of V is equal to 220 voltage, EB is equal to 200 voltage, and the value of RA, we consider the value of RA is 0.5 ohm. So the rated current, what is the value of the rated current at that time? 220 minus 200 by 0.5. That means what is the value of that?
40, sir. 40 ampere.
40 ampere. So the value is 40 ampere. And what is the starting armature current? Because at the time of starting there is no back EMF, so the value is, or say the value of
440, sir.
starting current is 440 ampere. So the permissible value through the armature coil is 40 ampere, and we flow at the time of starting the current value is 440. What will happen? If we flow 440 ampere instead of 40 ampere, what will happen? Ayush, Deepak, Manish, tell me what will happen?
Motor is in starting position, sir.
we are flowing 440 ampere at the time of starting instead of rated current 40 ampere. So what will happen? What will happen? The coil should be burned out, or it may be burned out. So to protect the armature from the, say, from the high current, what we should do, or say, suppose we have to control current through a path, what we should do? Ayush, tell me what we should do. We have to
So,
we have to limit the current through the armature part. So what we should do?
so we should gradually increase the voltage.
We should gradually increase the voltage. No, because the supply voltage is constant, and because we cannot reduce the supply DC voltage, because the uh, change in voltage level in DC is costly. So we don't do it. We actually give this constant supply, so we cannot gradually increase the supply voltage. So what should we do? We have to control the current through the armature path. In the armature path, a high current will flow.
सर रेजिस्टेंस लगा सकते हैं सर आर्मेचर पाथ में.
Good. We can connect a variable resistance by which we can control, the current of armature path. So we can say the starter is nothing but a variable resistance. And so why we need a starter? Tell me.
Motor requires a lot of current while starting, so we need a starter.
To reduce the initial high current, we need a starter. So what are the purpose of starter? Or why we need a starter? Why we need a starter? Tell me.
So we need a starter so that it will not burn the coils of motor.
Means at the time of starting there is a high current flow through the armature. So we have to control the initial high current or limit the initial high current. So we need a starter on that purpose. Have you understood?
Yes, sir.
So write down the Write down the purpose of starter. Number one, to limit the initial high current or starting high current. Number two, protect from overload and under voltage. Write down these two purpose of starter. Number one is to limit the initial or starting high current, and number two is protect the motor from overload and under voltage. These are the two purpose of starter. So next is types of starter. Write down types of starter. What are the types of starter? There are basically three types of starter we used for DC motor, or to start DC motor. We use three types of starter. One is called 2-point starter. Number two is 3-point starter. And number three, 4-point starter. There are basically three types of starter which we are used to start DC motor. These are 2-point starter, 3-point starter, and 4-point starter. So, Deepak, tell me how many types of DC motor are available? Deepak,
Yes, sir.
how many types of DC motor are available? How many types of DC motor are available? Manish,
Two types, sir.
two types. What are
Yes,
these?
sir. Uh, Shunt motor and series motor.
Sun motor and series motor. So, anyone have any other answer?
So three types.
Deepak says three types. Good. And the right answer is three types. And Manish says there are two types. One is shunt, another is series. But Deepak says there are three types of motor available. So one should be shunt, and number two should be
Series and
series,
compound.
and number three should be compound. So
Yes,
there
sir.
are basically three types of motor are available. One is called series, shunt, and compound. The 2-point starter is used only for series motor, and these two types are for used for shunt and compound type. So Samsat, tell me how many types of starter are available for DC motor?
So three types, sir.
Three types. What are these?
So 2-point starter, 3-point starter, 4-point starter.
And tell me which starter is used for which mode kind of mode.
सर 2-point starter सीरीज के लिए, बाकी 3-point और 4-point शंट एंड कंपाउंड टाइप के लिए.
Okay. Now one topic is 3 point starter. First we start with 3 point starter, then we go to 4 point starter, then we go to 2 point starter. First write down the heading 3 point starter. And draw that diagram, and then I will explain what is the function or in which way it will work. Draw that diagram.
Hello?
Tell me, have you complete?
Yes, sir.
हो गया ड्राइंग हो गया मनीष
Not yet, sir.
first draw the diagram then I will explain how it will work. And you should draw the diagram, don't take this screenshot. First draw the diagram then you can take a screenshot. आयुष ड्रॉ हुआ है आयुष
Yes, sir.
हो गया मनीष दीपक
हो गया सर.
मनीष
Yes, sir. हो गया सर.
खुशबू
Yes, sir.
यस
हो रहा है सर.
हो रहा है ठीक है करो this is a point this is another there are basically 3 points one is called a another is f and another is a that's why the name of the starter is 3 point there we mark or say in practical you can see there are 3 point or say there are three terminal in starter these are L, F, and A. L stand for line, F stands for field, and A stands for A stand for what means
Armature, sir.
armature. Good. That's why the name of that starter is 3 point. So first the current will go from current will flow from that line and current will see a coil. What is the name of that coil? OLC. The name of that coil is OLC. The full form of the OLC is overload coil. The name of that coil is overload coil. That means if there is the motor is overloaded, then this coil or say that system will activate. So we are moving forward. So this coil is actually activate when or say the function of that coil is happen when the motor is overloaded. So the current will go through this coil to that lever, and the current is stuck here because there is no way to go for the current. So this is basically off position of that lever, and a spring will connect on that lever so that it will rest on off position. That means if we move that lever from that off position to 1, 2, 3, 4, or 5, the spring will get back that lever to off position if we release that lever. That means due to the spring, the normal position of that lever is off position. So after that, we push it to say point 1 position. So what will happen? The current will flow through that path and also from that path. What is the path? Or say in this path the current will flow and go to a NVC coil, and the name of that NVC coil is no voltage coil. And after that it will go or it will flow through the field. That means this is basically the field current path, or the current will flow from this path is the field current. And the current will flow in R1, R2, R3, and R4, and then it will go to the armature. That means in this path the current which is flow is called armature current. So tell me first, when the lever position is 1, the armature current will flow from how many resistance? Manish, Deepak, Ayush, tell me, when the lever position is 1, how many resistance are in armature path?
4.
4. That means we can say a high resistance is inserted in armature path, and there is no resistance in field path. So the armature current or say the initial armature current or this initial high armature current can be reduced by inserting the resistance. So we add or say we added 4 resistance in armature path. So by this arrangement we actually reduce the initial high current. And when we put that lever on 2 position, what will happen? At the say 1 position, the value of armature current is What is the value? This should be the value of armature current at one position.
Yes, sir.
Then what will happen? A torque will generate due to the flow of flux and that armature current. Is that so? Ayush?
Yes, sir.
That means when the current is flowing through the armature and though there is a field, so a torque will generate at that time, and due to this torque the armature will rotate, say the value of at that time is n1. Due to that a1, a back emf will generate. A back emf will generate due to the this speed. So when we put the lever in two position, what should be the value of current? This should be V minus EB1 by RA plus R2 plus R3 plus R4. देखो समझ में आया कि नहीं आयुष मनीष
सर बैक ईएमएफ को माइनस किए
बैक ईएमएफ को
सर
V minus EB1 क्यों ऐसा किया
यस सर
because the equation of armature current is equal to V minus EB by RA, but at the time of starting there is no back EMF, so we write the value V minus 0. Basically here is the value is V minus 0 because at the time of starting there is no back EMF, and the resistance in the armature path is RA plus R1 plus R2 plus R3 plus R4. So due to this current and due to the flux, there is torque generated on armature, and due to this torque, a rotation will generate on armature. That's why a back EMF will form. That's why a back EMF will form on armature, and the next we push that lever from one to two position. At that time, what is the value of current? The value of current is Ia2 is equal to V minus Eb1 by Ra plus R2 plus R3 plus R4, because at that point there is a back EMF due to the speed, and the armature path contains R2, R3, R4 and Ra, the resistance, because the lever position is here now. So current will go from this path and that path. देखो समझ में आया कि नहीं आयुष मनीष
Yes, sir. But what is the use of OLC and NVC, sir?
अभी पहले ये समझ लो, फिर मैं बोल रहा हूँ what is the function of that OLC and NVC. So due to this current, there is a increment in torque. There is an increment in torque, so the speed will increases more, and the value of back EMF is also increase. So after that, we have to move to the position 3. After that, we'll move to position 3. What is the value of armature current at that time? Tell me. V minus EB2 by RA plus R3 plus R4. So by moving the lever from 1, 2, 3, 4, and will reach on position 5 final. Say we reach in 5 position final. This is the position is now. And what is the resistance on armature path now? Tell me how much resistance is on armature path at from position 5.
So there is only RA.
RA. And at that time the motor will rotate at the rated speed because there is no resistance inserted on armature path. So this is the basically full load, or say this is basically the final equation of that motor, and the motor will run, or motor will rotate at rated speed. Have you understood what is the procedure, or say how the 3 point starter will work?
Yes, sir.
Now we have to elaborate what is the function of NVC and OLC. Suppose the lever is in position 5, and at that time there is power cut. After say 2 and 3 seconds, the power will again come, and what will happen at that time? Suppose the lever is in position 5, and at that time the power cut happen, and say after, say for simplicity take, for after 1 minute the power is, or we get the power supply after 1 minute. What will happen at that time? Tell me. मान लीजिए 5 पोजीशन पे था, तब पावर कट हो गया, फिर 1 मिनट बाद पावर आ गया, क्या होगा?
So there is this chance of burning, sir.
Yes, there is possibility of burning the armature coil. So when the power cut happen, so the lever position should be go from 5 to off position. If there is
Yes, sir.
power cut, then the position of the lever should be from 5 to off position. And suppose there is no NVC coil, and the lever is in high position. How the lever is say the how the liver go to the 5 position, तो कैसे गया लिवर 5 पोजीशन पे आयुष? ओके, ऐसे ही चला गया कि हम लोग लेके गए वहाँ?
सर हम लोग लेके गए।
लेके गए क्या मतलब जब मोटर when the motor will run at full load or say for 1 hour, we have to hold that lever on 5 position. मान लीजिए एक मोटर 1 घंटा चलेगा, तो हमें वो 5 पोजीशन पे ही होल्ड करके रखना है.
यस सर।
There is a spring connected with that lever. So if we release that lever, what will happen? हम अगर उस
से
लीवर को
वापस
छोड़ देंगे तो क्या
ऑफ
होगा?
पोजीशन,
It will go,
ऑफ पोजीशन का जाएगा।
it will goes to off position. तो मतलब उस 5
यस
पॉइंट
सर।
में कुछ अरेंजमेंट करके रखना है जिससे वो लीवर वहीं पे रह जाए. हमें कुछ ऐसा अरेंजमेंट करके रखना है जो 5 पोजीशन में जब तक वो मोटर चलेगा तब तक रहेगा. आया समझ में आयुष? आयुष? आयुष?
यस सर।
समझ में आया?
यस सर।
तो 5 पोजीशन में हमें क्या करना है, वो उस लीवर को होल्ड करके रखना है. हम अगर छोड़ देंगे तो स्प्रिंग उसे ऑफ पोजीशन पे ले चला जाएगा. That means there should be some arrangement by which if we release the lever on 5 position, that it will rest on 5 position when the motor will when the motor is running. When the motor is running, so the position of lever should be on 5. Though there is a spring arrangement, that means we should provide a counter force by which we can rest the lever on 5 position. आया समझ में आयुष?
यस सर।
Okay. Though the time is over, so we have to stop here. I will discuss in next class. So don't worry. So I'll take the attendance. Ayush,
प्रेजेंट सर।
Deepak,
प्रेजेंट सर।
Manish,
प्रेजेंट सर।
Yash,
प्रेजेंट सर।
Khushbu,
प्रेजेंट सर।
Samsad,
सर।
Sujit, Ravin,
प्रेजेंट सर। प्रेजेंट सर।
Danish,
प्रेजेंट सर।
Asgar,
प्रेजेंट सर।
Sumira.
प्रेजेंट सर।
Okay, you may leave now.